Welcome back to our journey talking about proportional relationships. In the last lesson, we looked at tables and we decided if they represented a proportional relationship or not. Now we're going to take it to the next level and we're going to look at proportional relationships and learn how to represent them with an equation. And the nice thing about these equations is we can use them to predict future things or predict larger amounts or smaller amounts. For example, if 625 oranges are in 25 trees, then how many oranges would be in 70 trees? So writing an equation and using it is one method that we could use to solve this problem. Go ahead and pause, figure out where this goes in your table of contents, and write down the EQ. So today we're going to focus on representing proportional relationships with an equation, and we're going to look at how these equations can be used. All right, again, go ahead and pause, copy down this vocab. All right, so our equations are going to be in the format of y equals kx. So the y and the x are always going to be there. The k is going to be what changes. The k represents the constant of proportionality, and that just is basically our constant rate of change that exists between our x and our y. Our dollars and pounds, our lawns and dollars, our donuts and boxes, whatever the heck relationship we're looking at, that's our x and y. And the way we figure out k is just like we were doing to identify the proportional relationship. We're going to divide y over x. So always, always, always y over x, y over x, y over x. So our steps are pretty simple. Go ahead and pause and write them down. So to find k and write in our equation, we're going to go y over x to get our k. We don't have to do it every single time because if it tells us it's proportional, then guess what? Every single y over x is going to be exactly the same. And then we're going to write it in the y equals kx format where k is whatever the heck we got here when we divided y over x. Sounds complicated. It's actually way easier than it sounds. All right, here's an example. 2 pounds of cashews cost $19 and 8 pounds cost $76. We're going to prove that it's a proportional relationship, and then we're going to write an equation for the relationship. All right, so do I want pounds per dollar or dollars per pound? So as we learned before with unit rates and everything else, dollars usually goes on top. So this is our y, this is our x, and we know that k equals y over x. So we're going to go y over x, y over x, y over x. So 19 divided by 2 is 9.5. 28, 50 divided by 3 is also 9.5. And 76 over 8 equals, you guessed it, 9.5. So this is a proportional equation, a proportional relationship, excuse me. And so we're going to write it in the format of y equals kx. And what is our k that we found? It's 9.5. If we wanted to describe this in words, we would say the cashews cost $9.50 per pound. Here's another relationship with just a table. So here's our x, here's our y. So a lot of people want to take this number and divide it by that number and be done with it. But what's the issue there? That is x divided by y. And what do we want to do? We want to go always, always, always y over x. So we're going to take our y number, 750, divided by our x number, which is 6, and we're going to divide these things. So I'm going to go 7.5 divided by 6, and totally fine to use a calculator, and I'm going to get 1.25. I don't need to do every single one because it's not asking me to prove that it's proportional. Okay, we're just assuming it's proportional because it is. And now we're going to write our equation in the y equals kx format. So what did I find as my k? And remember, k equals y over x. So what did I get there? I got 1.25. So when I go to write my equation, I'm just going to slip that in for k, and it'll look like this. Y equals 1.25x. Okay, pause and copy this table down. And let's write an equation for it. So k equals y over x. What's my y? What's my x? So I'm going to say k equals 3 over 2. And it's okay to leave it improper, and you'll see why when we get to the 8th grade proportional and non-proportional relationship equation stuff we're going to spend some time in. But we can also write it as 1.5, or we could write it as 1.5. Whatever makes you happy and whatever works best in the situation. So for now, we can use this. And we're going to write our equation in the y equals kx format. So y equals, and instead of k, what am I going to put? 1.5x, like that. Boom, there's my equation. All right, let's try one more. Go ahead and pause and write this thing down. All right, let's make an equation. I know that k equals y over x. If you ever see double zeros, you're going to skip it. And why are we skipping it? Because you can't divide by 0, can you? That's undefined. So we're going to skip the 0 level and we're going to go here. Oh, this is going to be really easy. Y over x. So k equals 3 over 1, which is 3. And so when I write my equation, I'm going to write y equals k, which is 3x. That's it. Pretty simple. Go ahead and hit pause, copy these down, and give them a try on your scratch paper. All right, make sure to come in tomorrow with those 2 problems worked out on your scratch paper. Be sure to write them in y equals kx format, and be sure to show up with any questions that you have. And then tomorrow we'll practice, make sure we're good, and then we'll look at how we can apply those equations to solve problems. All right, get a good night's sleep, and I'll see you in class tomorrow. Bye.